Okay, today we're going to look at one or two more little topics from Chapter 2, Section 8. First off, we want to look at what's called composition of functions. Essentially, the idea is we're used to, say, having a set x right here, and then we have a set y, and we have some function f that goes from x to y. Now we want to create another set, maybe z, and another function that goes from y to z called g. Composition of functions essentially allows me to start from x and go over to z by writing this new function, which we write as f circle g. And we actually draw a circle, it's called f circle g. It means f composed with g. And essentially, f goes from x to y, g goes from y to z, f circle g goes from x to z. And the way we actually use it, let's see. Suppose we have f of x equals 2x plus 3, and g of x equals x minus 2 squared plus 1. We want to find f circle g of x. By definition, f circle g of x is just f of g of x. Just replace g of x with what? We'll rewrite it with g of x in the inside. Now do a substitution. Replace g of x with what g of x is. So that's f of g of x, which is x minus 2 squared plus 1. Now, take this and apply f to it. And this is the part where you have to be careful. What does f do? It takes whatever I plug in this case, x minus 2 squared plus 1. It takes that, multiplies it by 2, and then adds 3 to it. And there we go, f circle g of x. As far as algebra goes, if you want to FOIL this out and combine like terms and distribute the 2 and combine like terms again, if you want to do all of that, you can. I'm fine with you leaving it like that, just so I can see the composition. This is g of x on the inside, and then you apply f on the outside. 2 times this plus 3. As another example, this composition can be done a lot of different ways and in different orders. In theory, we could find g circle f of x. But it works the exact same. G circle f of x is g of f of x. And then by definition, replace f of x with f of x, which is g of 2x plus 3. Now, apply g to this. So what does g do? It takes whatever you plug in. We're plugging in 2x minus 3. And then let's see, subtract 2 from it. Then square the whole thing, make sure your parentheses are in the right place, and then add 1 to the outside. And there we go. And again, we can see the f of x on the inside, and then the whole g of x on the outside. When you're doing this, again, if you want to combine like terms and FOIL, you can. I'm not all that concerned with it. As one more example, suppose we have f of x equals 2x plus 4. Find f circle f of x. By definition, that's f of x. Now, replace f of x with what f of x is, which is 2x plus 4. And then apply f to that again. What does f do? It takes whatever you plug in our case 2x plus 4, multiplies it by 2, and then adds 4. And there we go. We can see the f of x on the inside and the f of x on the outside. We are going to mess around with these composition of functions again later on in Chapter 4. For right now, we just want to get the basic idea. Given two functions, find their compositions. And keep in mind, from the work we've done, f circle g is not necessarily the same as g circle f. So just plug in, work out, do the algebra. Don't assume anything. there are a few other things we can do with our functions, and essentially we have all of our basic binary operations: addition, subtraction, multiplication, and division. And once we have those operations, then we can apply them to anything we want. In this case, to functions. As an example, again, suppose we have f of x equals 2x plus 4, and g of x equals x minus 5. Then we can find the sum, f plus g of x. But as far as it goes, f plus g of x is just f of x plus g of x, which is just f of x, 2x plus 4, plus g of x, x minus 5. And then here we could actually combine like terms. 2x plus x is 3x, 4 minus 5 is negative 1, and we're done. That's pretty straightforward, and the same principle will apply for our other operations. So suppose we have f minus g of x. Well, that's just f of x minus g of x, which is, let's see, f of x, 2x plus 4, minus g of x, which is x minus 5. Here, for subtraction, parentheses are important. Make sure you separate things with parentheses. F of x minus g of x, because this negative has to be distributed into every term of g of x. So make sure you put your parentheses in the right places. But then this becomes 2x plus 4 minus x plus 5 minus x minus negative 5. Two negatives cancel, and that's plus 5. And then combine like terms. 2x minus x is x. 4 plus 5 is 9. There's two more operations we want to run through, and then we're going to do something else to finish. So we'll keep our same f of x and g of x. But if we get addition and subtraction, we also have multiplication and division. So suppose we get fg of x. Well, obviously that's just f of x g of x, which would just be f of x, 2x plus 4, times g of x, x minus 5. Again, make sure of your parentheses, make sure everything is written correctly. And now FOIL those out. 2x times x is 2x squared, 2x times negative 5 is negative 10x, 4 times x is 4x, 4 times negative 5 is negative 20. And then I guess we get 2x squared, negative 10x plus 4x is negative 6x, minus 20. And there we go. And again, that's just basic foiling stuff we can do. The last one, f divided by g of x. Well, that's just f of x over g of x, which we can just write as 2x plus 4 over x minus 5. And in this case, we're done. There's nothing else we can do. So all things being equal, there isn't much we have to do for these operations on functions. Earlier in the semester, we did applications of functions, plugging in values, evaluating them. This is essentially the same thing. Take your functions, add them together, subtract them, multiply them, divide them, whatever. Nothing really new, but your book mentions it, so I just wanted to go over it briefly. The one thing I would point out, once we define new functions, we care about the domain of our function. We have talked about the different ways to determine your domain. But as far as it goes, for, say, these ones right here, the domain of f is all real numbers, the domain of g is all real numbers. When you add them together, you get all real numbers for your domain. When you subtract them, you get all real numbers for your domain. When you multiply them, you get all real numbers for your domain. Nothing changes. If we remember the two rules for our domains, you only have a problem if you have a square root with an x inside of it, or if you have a fraction with an x in the denominator, and the possibility of having a 0 in the denominator. And here, when we divide, we'll always be putting an x in our denominator, which means technically our domain will change. The domain of f is all real numbers, the domain of g is all real numbers, the domain of f divided by g, you can't include x equals 5, because that would give you 0 here. So just be aware of that. Use our old domain rules. The only time they'll pop up is when we do division, f divided by g. because we'll end up possibly having a 0 in the denominator. Okay, there's one more trick I want to go over, but I don't want to make this video too long, so we'll come back to it in the last section.